Good morning, students. In the previous class, we have discussed about biconnected components and example for finding articulation points for a given graph. So there is an algorithm for finding articulation points for a given graph. The algorithm consists of 4 steps. Step 1 is construction of DFS tree for the given graph along with the depth first numbering, and step number 2 is adding back edges. Step number 3 is finding L values, and step number 4 is by observations you have to find which vertex is in articulation point and which vertex is not in articulation points. In the previous class I have explained you with one example. In today's class I will explain you with one more example. See this example. So this graph consists of 8 vertices named as A, B, C, D, E, F, G and H. So what is the first step in finding articulation points and the algorithm? Construction of DFS tree along with the DFN. So this is the DFS tree for this graph. So how to find DFS tree? So initially take first step vertex as A, and next what are the adjacents of A, B and C? I visited vertex B. So given numbering as 2 for vertex A, given DFN as 1. The adjacent for B is A and D. A is already visited. So next I am visiting vertex D with the DFN number 3. And for the vertex D, adjacents are C, E and F. Anything we can visit. Those first I am visiting vertex E. So DFN number as keep DFN number as 4, and for vertex E adjacent is D and F. T already visited, so next take vertex F, give the numbering as 5. For vertex F there is no adjacent, for the vertex F there are 2 adjacents D and E that are already visited, so apply backtracking. So come to E. For adjacent vertex E, adjacent is D and F already visited, so again apply backtracking. For adjacent T, for vertex D, the adjacent is B, E, F and C. B already visited, E also already visited, so F already visited. Next visit vertex C with the numbering as 6, and for vertex C adjacents are A, D, G and H. A, D already visited, either you can visit vertex G or vertex H. I am taking visiting vertex as a G and numbering as a 7, and for vertex G the adjacent is H and keep DFN number as a 8. So this is the procedure for construction of a DFS tree. This is the first step. Hope you all have understood. And step number 2 is adding back edges. So what is a back edge? Back edge means the edge which is present in the original graph and not present in the DFS tree. Such edges are known as back edges. So identify the back edges by comparing these two diagrams. So what are the edges that are present in the original graph and not in DFS? So check here, AC. So edge AC is not here, and next one is CH, AC, CH, DF. AC, CH, DF are the back edges. So step number 2 is adding back edges, and step number 3 is calculation of L values. So what is the formula for finding L value? The formula is minimum of DFN of U, comma, minimum of L of W, where L is a child of U, and minimum of DFN of W, where U comma W is a back edge. That I already discussed in the previous class. So before going to find the L values, so you have to find L values in the order of either postfix order or in the DFN reverse order. Anything you can take. In the previous first example, I have calculated L values based on the postfix order of the DFST. In this example, let us calculate L values based on DFN reverse order. Anything you can take. So what are the DFN reverse order? 8, 7, 6, 5, 4, 3, 2, 1. So according to that, write the corresponding vertices. DFN 8 for H, DFN value is 8. So I have written H. DFN 7 is for vertex G. So I have written G. Similarly, write all the vertices corresponding to the DFN values in the reverse order. In this order, let's start the calculation of L value. So how to find L value of H? So minimum of DFN of H. So what is the DFN value of H? 8, comma. Is there any child to H? So there is no child node to the vertex H. So keep it as empty. Is there any back edge from the vertex H? Yes, there is one back edge from the vertex H. That is from H to C. So what is DFN of C? DFN of C is 6. So minimum of 8 comma 6. The value is 6. And next L of G. DFN of G is 7. For G, you are having one child node H. So L of H is already calculated previous 6, and for G there is no back edge. So the minimum is 6. Coming to the C, DFN of C is 6. For C, only one adjacent you are having G. So L of G is 6, comma. From C you are having one back edge. So DFN of A is 1. So the minimum is 1. L of F, DFN of F is 5. There is no child for the vertex F. So keep it as empty. And there is one back edge from F. And the DFN value of D is 3. So I have written here 3. The minimum value is 3. Next for E, DFN of E is 4. For E, one child node is there F. L of F is already calculated here 3, and there is no back edge from the E. The minimum is 3. Coming to the D, DFN of D is 3. For D, you are having two child nodes. One is E and other is C. Okay, take L value of C as well as L value of E. So compare and take the minimum value. So L value of C is 1 and L value of E is 3. So once again I am repeating, for vertex D you are having two child nodes. First one is C and second one is E. If any vertex is having two child nodes, take the L value as a minimum which the vertex is having. So for C L value is 1 and for E L value is 3. Among 3 and 1 the minimum is 1. So take value as 1 and there is no brackets. The minimum is 1. Next L value of B, DF1 of B is 2 and you are having only one child for vertex B, and L value of D is already calculated here 1 and there is no brackets. So the minimum is 1. Similarly, find out for A, DFN of A is 1, A having only one child node B. So L value of B is, sorry, here you have to write 1. L value of B is, change it as 1. Dear students, please make a note that change it as 1. The minimum is 1. So these are the L values for the vertices A to H. And the step number 4 is identify which vertex is in the articulation point. So A is a root node. It is having, since it is having only one child, so it is not in a articulation point. F and H are the leaf nodes, so they are not in articulation points. And the remaining vertices are B, C, D, E and G. So you have to check the formula. L of W is greater than or equal to DFN of U. So B is having one child. So L of D is greater than or equal to DFN of B. So B is not in articulation point. Similarly, calculate for C. C is having one child. So L of G is greater than or equal to DFN of C. Here the condition is satisfied. So C is an articulation point. Coming to the vertex D, it is having two childs. You have to check the formula. for two vertices, for vertex E and vertex C. If any vertex satisfies this condition, then that particular vertex is in the articulation point. For example, see here, for vertex C, the condition is not satisfied. For vertex E, the condition is satisfied. So, the vertex D is in the articulation point. E is having one child F. So, condition does not satisfy. So, E is not his articulation point. Similarly, G is not a articulation point. Therefore, for the given graph, only C and D are the articulation points. Thank you.